All right, let's continue with 8.1 notes, and this is regarding Fibonacci sequence. And you may actually know about this already, but let's look at what that is. So next example, example 3, is to find the first 11 terms of the sequence defined recursively, which we just went over in the previous video, by f of 1, meaning Fibonacci at position 1 is going to equal 1. The sequence at position 2 is going to equal 1. But the position at any number is going to be f of n minus 1 plus f of n minus 2. Well, n minus 1 is defined before is the previous number to the position you're at. Well, let's go through that a little bit. So if I did, we know what f of 1 is. We know what f of 2 is. What's f of 3? So f of 3 would be f of 2, because 3 minus 1 is 2, plus f of 1, because I would be going 3 minus 2, which is 1. We know what f of 1 and 2 are. They're both 1. So this would be 1 plus 1, which equals 2. So I know in position 3, I have 2. What happens in position 4? I would be taking f of 3 plus f of 2. Those are the prior two numbers in the sequence, because that's what this form actually means. Well, the prior two numbers would be position 3, which is 2, plus position 2, which is 1. And I would get 3. So what happens at position 5? I would have position 4 plus position 3. Well, what are those? That's these prior two positions. That's 3 plus 2. That equals 5. So let's write that out. It says find the first 11 terms defined in the sequence. So the first term, the f of 1, is again 1. And then the next one is 1 as well, because that would have been my f of 2. And then my f of 3 is 2. My f of 4 is 3. F of 5, or 5 happens to be 5. So let's label those. F of 3, f of 4, f of 5. And if you continue through, you will find that the next numbers are 8, 13, 21, 34, 55, 89. That's f of 6, f of 7, f of 8, f of 9, f of 10, and f of 11. And that's the first 11. And we can go dot, 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 because the sequence continues on. We were able to answer that question. You may want to try a couple of these and make sure that you have them down before you move on. What about finding, what if we're going to need to find or finding partial sums of a sequence? What is the definition of that? Well, these are defined as the following. We have S of 1 would equal position 1. S of 2 is taking the first two positions, whatever they are. I'm going to scoot it up, sorry. S of 3, S meaning the sum, is defined by S, and then would be the first three positions, because it's a total of the three numbers. And we would continue on, say S of 4 is going to be the first four numbers. Oops, that should be a 2, plus A of 3, plus A of 4. And I can go dot, 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 all the way down to the sum at any number. so you decide which number you're going to, is going to take the sum of all those numbers up until that position. So I'm going to go dot, 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 because we don't know. It can go to whatever position you want. So maybe you want the 25th. So I would go to the 25th position. And that would be the definition of what a partial sum is. We're also going to find out in the next lesson about what the formulas are for the partial sums of a arithmetic sequence. So let's try another example. We're going to do example 4. Find the first 4 partial sums and the nth partial sums of a sequence, and it's given as a of n equals 1/2 to the nth power. That is our item. Well, let's start answering it. It's asking for the first 4. Well, let me scoop this up a little bit, guys. And we have, what's S of 1? Remember, it's the first position. So it'd be 1/2. And nothing else is added. What's S of 2? It's going to be, think about this, we're plugging in the n value. N value on the first one is 1. So it's 1. Plugging in 2. What is that really meaning? It is meaning that you're taking by partial sums. I'm taking the first position. What's the second position? That's going to be 1/4 when you square both numerator and denominator. So partial sums mean I need to add them both up. You get a common denominator, do all of that. You're going to get 3/4. And then I have, what's S of 3? Well, that's going to be the first 3 terms in the sequence. So I have 1/2 plus 1/4 plus, what's my a of 3? We'll plug in 3. I have 1 cubed is 1. 2 cubed is 8. So that'd be 1/8. Then you're going to add them together, and I get 7/8. What if I do S of 4? I need the first 4 numbers. So I have 1/2 plus 1/4 plus 1/8. Now what is that? N value is the 4. That doesn't look a very good 8, by the way. N value is 4, and take both 1 to the 4th and then 2 to the 4th, and I would have 1/16. Add those together, common denominator is 15/16. And we can go dot, dot, dot. What is S of n? It says the nth term of the sequence. That all that is I'm taking all the terms and adding them together. So I have the first term, the second term, the third term, plus the next several up until, whoops, I have a of n being the last term in the sequence that you decide it to be. Maybe it asks for the 50th term, but this is asking for the nth partial sum. It's just adding all of those up, and that would be the answer. Now let's move on to sigma notation. I love this notation. It's so much fun. Well, let's get a clean sheet of paper. And let's talk about sigma notation. So much fun. So I have sigma notation. And it's just a fancy way. You can really blow some minds with this, that you know what it means. It looks like an E, a big E, but it is definitely straight lines and it's curved in. So what does that mean? Well, I find it's easiest to understand with a problem. So let's actually just set up one, and let me get the other color. So example, let's set up and let's notate what this means. So I have maybe sigma, the sign, and then I have a number on the bottom, and let's say it's K. Sometimes it's X, sometimes it's T. It could be any letter it wants to be, but it's going to be equal to some number, typically. And then the top, let's just say it's a number 5, and this says maybe K squared. What does all of that mean? Well, this sigma item means to just add. It's a sum. You're just going to add them up. And this item here tells where you start. Start. That's also known as a lower bound. You might hear that terminology in another spot. So it just tells you I'm starting at the unknown or the value of 1 in the function. And then that means if that's the lower bound, then this item at the top is going to is considered upper bound, and it tells where you stop. So with a summation, you need to know where you're going to begin and where you're going to end. Where, I forgot to put you, where you stop. Okay, what is this thing right here then? That is your function. That is what you're plugging everything into. So by notating all of that, just knowing what it is, you can start to solve it. Well, that would equal, if I start at position 1, or K is 1, 1 squared plus what's the next number in the order between 1 and 5? Well, that would be 2. So it would be 2 squared plus the next number in the order. That would be then 3 squared plus the next 4 squared plus 5 squared. And that is where I stop. I stop at 5. Then you just do your math, and the sum ends up being the number 55. So it's really pretty cool. Let's do one other example where it doesn't have all the naming of it on. And we're going to call that one example 5, writing sums in sigma notation. Please know your terminology. All right, our given information is going to be square root of 3 plus square root of 4 plus square root of 5 plus ... plus square root of 77. All right, I need to transpose that sequence into sigma notation. All right, not a problem. Let's start. There's a couple ways you could do it. If one of the ways is starting with noticing they're all under radicals, and it goes from 3 to 4 to 5, and so they're going by ones. All right, I can write, here's my sigma. I'm going to use the letter K again. So K is going to equal my lowest position is going to be 3. But how would that look? I would have to have the function being a square root of K, because it's the square root of the input of that number. Well, the first one in this sequence is a square root of 3. So my lowest value is going to be 3, up to my highest value of 77. That's where I'm going to end. We can also say, well, what if I want to say I start at 1? So I could go, there's a couple ways again. That's the awesome thing about math. There's sometimes many ways to the same. Well, if I want to start at being 1, what would my function need to be? Well, I would have to have 1 plus 2, then 1 plus 3, or could I go my input? I could actually do square root. Let's test it. Would I have k, whatever k value, because I misspoke a moment ago. What if k is 2? The next one would have to be 2 plus something. If k is 3, it would have to be 3 plus something. What's the constant that is added? Well, 2 is added each time. We'll try it out. Okay, 1 plus 2 is 3. If k was 2, 2 plus 2 is 4. If k was 3, I would have 3 plus 2, which is 5 for position 3, and so forth. So what's our highest? Well, our highest that we could go is 75, because 75 plus 2 would give me 77. Okay, some books require that, or some professors require that you start at either 1 or you start at 0. So here's another one. Summation. What if I have to say that it starts at 0? What would I be putting in? Well, at position A of 1 would be 0. So 0 plus 3 would be 3. At K being 1, which is position 2, I would have 1 plus 3 is 4, and so forth and so on. So our function would be k plus 3, and our top value that we could put in to make it 77 is 74. So 3 different ways, and you'll see typically the middle one a lot, and this is the most simplistic, but that middle one is used quite a bit. I hope this helps. Good luck studying.